Alright, so let's have a look here at this little modular rig. For the moment we have a sine wave playing, which is coming from this oscillator. What it looks like, we see the oscilloscope, we see the waveform. If I move the pitch, this is our starting point. We have another oscillator here, which is basically the same, playing again also just a pure sine wave. So we have those two oscillators, and the great thing about these oscillators is in fact they have a pulse width modulation input. As you can see here, PM for pulse modulation. I have here an LFO, taking the output of the LFO. You see the cable blinking at the speed of the LFO. I'm plugging this to the pulse width modulation input, and what's happening? I will increase the pulse width modulation. And what you see are slow drifts because it's moving faster or slower through the phase, a bit like a Doppler effect, right? Remember we spoke about Doppler effect in the previous video. Let's increase that a bit. Let's make it faster. Or let's go even faster. And now we see the wave shape is totally shifting. Look at the screen. You have this portion where it's very slow, and this portion where it's very fast. But this is doing slow speed modulation. What would happen if I would take this modulation, and instead of controlling this modulation from an LFO, now instead of taking this modulation from the LFO, I will take it from the other sine wave. Out of a sudden now I create phase modulation. This is proper phase modulation, like people would call it FM. The stronger the index, the higher the harmonics. Pure tone. And I have, of course, the control over the pitch of the second that impacts the partials and the harmonic spreading of those. Let's have some fun here. I'm tuning this kind of to a harmonic ratio, and now I'm going to shift by octaves. This exactly sounds like an FM synthesizer. But I can do more funny things with this, because here I'm just using one classic sine wave to modulate another one on the pulse. But what would happen, for example, if instead of doing that, now I'm taking this complex waveform. For the moment it's a pure tone. I'm taking its output and I'm sending the output. I'm listening both to that output, but I'm also sending the same output to a filter. And as you know, filters are devices that induce phase shifts. So I'm making phase modulation of the oscillator on its own, but the modulator signal goes through a filter. And now I can start bringing feedback. Weird things start to happen. Now the funny thing is, I can also modulate the pitch of this first oscillator. I have here some slow envelope with no modulation. We just hear the pitch moving. But now that I will call in the modulation, because the pitch changes, the frequency changes, so the phase ratio is not the same, but it goes through the filter. But I can also add some control over the frequency of the filter modulation. We start to create some really weird artifacts and interesting tones, only playing with the oscillator, filtering its signal and feeding it back as a modulation of its phase. This is one type of synthesis technique that is called feedback. We are feeding something back to itself to create interesting results.